right, friends, how are we doing? So, for our second day here on sampling distributions, we're going to be talking about how to describe a sample distribution of p-hat. Kind of what we talked about when we left off from our last lesson. So, sampling distributions, again, are going to be a plot of every single sample statistic. So, proportions, means, medians, all of those are numeric values in a distribution that we create. And so we're going to use SOCs to describe them, and that's what we'll be looking at today. Now, when you are taking an actual sample, we are trying to gather either quantitative or categorical data. So that's the type of data we'll be focusing on, and we're going to be looking at two different types. So on the first day of school last year, actually, I asked everybody, what is your political affiliation? And in this case, well, that's going to be categorical data, right? So anytime we're looking at categorical data, when we're making a sampling distribution, what we're really asking is what proportion of my population falls within specific categories. So at last class, you said you took a look at your random number table, your graphing calculator, and you saw that p-hat is what you should be having here. Okay. And you looked at what proportion of students were identified themselves as Republican. And then you compared each of those different categories. So all of these should be p-hats here. I apologize for not having that ready for you. Yep. Now, the true population parameter that we found last class was that 36% of individuals were Republican, identified themselves as Republican. Now, as we increased our sample size, we saw that those values became more symmetric. So I'm skipping over that since we did that last class. Hopefully we did that last class. And we saw that the shape gets closer and closer to being symmetric and closer to being approximately normal. We get a little bit more accurate. And we notice that there is a smaller spread or variability. Which makes sense, right? If we take a larger sample size, we are taking more individuals. It's less likely that we will stray from that true population proportion. So, what are some big SOCs, pieces of information that we need to know? Well, assuming that our sample size is large enough, our sample distribution of every possible sample proportion. Remember, what a sample distribution is if I took every single sample out of the population of a certain size group. So we did 3 teachers, right, when we introduced this. If I took every possible combination of 3 teachers and we mapped the medians when we created our first sample distribution. Well, what if I did the same thing with proportions, right? What if I took every possible sample of size 10, right, every group of 10 students from my class, and I plotted the proportion of Republicans in every single one of those groups, and I plotted every single one of them. Well, that distribution would look normal, or closer and closer to being normal, as I increase my sample size, right? In order for us to say that that shape will be approximately normal, because we don't know for sure, the sample size times the true proportion must be greater than or equal to 10. And the sample size times the proportion, that's the same thing, sample size times 1 minus the proportion must also be greater than or equal to 10. If both of these conditions are met, then we have a large enough sample size to say that our sampling distribution is approximately normal. The mean of our sampling distribution of p hat is going to be the same as our population parameter. So the mean of every possible sample proportion is going to be equal to whatever the actual proportion is for the population. The spread, or the standard deviation, since we're talking about normal, that's what's most important to us, is going to be the square root of p times 1 minus p all over n. So there's our shape, center, and spread. These formulas for center and spread are given to you on the AP formula sheet. Right, and again, this should be a p hat there. So, how can we use this to our advantage? Well, let's say we know that our population of young adult internet users, so internet users from 18 to 29, that watch online videos is 75%. 75% of young adult internet users watch online videos. And we take a sample survey of 1,000 of those young adult internet users and calculate the proportion in the sample who watch online videos. Okay. What would the shape of that be? Well, as long as n times p is greater than or equal to 10 and n times 1 minus p is also greater than or equal to 10, that means that our sample distribution will be approximately normal. Well, n is our sample size, so we know that if I take 1,000 individuals, multiply it by p, so 0.75, we know that that will be greater than or equal to 10 because 750 is greater than or equal to 10. We also know that 1,000 times 25% is going to be greater than or equal to 10 because 250 is greater than or equal to 10. So we know that the distribution of every possible sample proportion I could get if I take 1,000 individuals out of this population, so every possible proportion of 1,000 individuals, we know that that's going to be approximately normal. We have a large enough sample size that will be true. What's our center going to be? Well, the mean of that distribution should be equal to the actual population proportion. So the mean, the center of that distribution, will be 75%. The spread, well, in order for us to be able to meet the spread, we have to do something called checking the 10% condition. And that's because as I take more and more individuals out, we're not actually doing an independent survey, right? If I take the first person out and they watch the internet, then it's a little bit less likely, or that they watch online videos over the internet, then it's a little bit less likely that the next person will also watch online videos. So in order to kind of rectify that, or in order for us to show that, okay, there's a small enough change that it's minimal and we don't really have to worry about that, we check something called the 10% condition. And that's that our population size must be greater than or equal to 10 times our sample size. Okay? So we're taking a small enough group of individuals out of our all young adult internet users such that the change in the probability of the first person watching an online video and then the second person watching the online video, the change in probability of that occurring is very, very small. All right. Well, in our case, we don't know what the population size is, but we do know that our sample size is 1,000. Now, is it safe for us to assume that there are more than 10,000 young adult internet users? Yes. And because of that, so check. Again, our shape, well, I'll go back over this one more time. Because of that, we know that our spread is going to be the square root of p times 1 minus p over n. For us, that would be the square root of 0.75 is 1 minus 0.75 or 0.25, you can write either, over 1,000. Which would be, if I can get my key, oh, I guess I didn't put this in my key. All right, let me get my calculator. Sorry about that. Yay, wait time. That would be about and you could round to 3, 4, or even 2 decimal places here, but I rounded to 4, so 0.0137. So again, if I was going to draw this, and I'm going to do that on the next page, okay. If I was going to draw this, curve down here, I would say, all right, because n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10, if I was going to plot every single sample proportion, I could draw it as an approximately normal curve. Okay. So again, what's being shown here? Well, these are every single possible p hat, right? For our population, for our population distribution, it would be every single person, right? Here, this is every single possible p hat, right? These are all the possible p hats. I could choose this p hat, I could choose this p hat, I could choose this p hat. These are all p hat values, every possible p hat value of a sample of 1,000 individuals, right? All p hat values here, right, as opposed to individual values. Okay, so I have all of these possible choices of different p hat values I could choose from. All right. So again, mapping every single possible p hat. The center of this, the mean value for all of these p hats, our center here, would be 0.75. Right? Now, what we're going to do is try to find the probability that I could choose a p hat of more than 77%. Okay? So that's going to be above, and that's going to be almost 2 standard deviations above. So we have 1. We have 2 here, and let's just say That 0.77 is here. So what I'm trying to figure out is, of all of these possible p-hat, what proportion, or what's the probability that I choose one of these p-hats that's greater than 77%? Okay? And again, this represents the sample proportion sample proportions of young adult internet users. I should have done a capital Y there, but whatever. That watch online video. You can use p-hat here later. Okay. You can use p-hat here later, and I'll show you how to do that here. So we're looking for that. What's the proportion up here? Well, they're asking us to use our z-score table. So the first thing we're going to do is calculate our z-score. I can do that because I have a normal curve. We know that z-score normally is equal to x minus mu over sigma, but in this case, we're talking about what's the sample proportion we're looking for, minus the mean of every possible sample proportion divided by the standard deviation of every possible sample proportion. And for us, that would be 0.77 minus our mean of 0.75 over our standard deviation that we calculated up here of 0.0137. When I calculate that out, I will get a z-score of about 1.46. Then I can look in my z-score table for 1.46. So I look for 1.4 and then go over to 0, 1, 2, 3, 4, 5, 6, and I find that the probability that I'm less than that is 92.8, but we want to be greater than that, right? This area that we've shaded is actually bigger than that. So that would be 1 minus 0.928, which would be equal to 0.072. So for every possible sample proportion, about 7.2% of them have a proportion of greater than 77%. So probability at more than 77% of a sample watches online video is 7.2%. And I apologize for Alright. Now, what's a quicker and easier way to do that? Well, our calculator. And let's do the 4-step process to practice that. So let's start with our state. First thing we're going to do for state is define our variable. So let's let p hat equal the proportion of a sample of 1,000 young internet users who watch online video. And I'm sure this is much higher than what we said now. Right? So that's the first thing we do. We define what is our proportion of what is our p hat value going to be. Now, what are we looking for here? Well, we're trying to figure out that we are within 1 to 2% of the true population proportion, or within 2% of the plus or minus 2% of the true population proportion. Well, what's the true population proportion? Well, they've told us that it's 75%. So we're trying to figure out the probability that we're within 2% of that. So what's 2% of that? Well, that would be between 73 and 77%. Now, for our plan. Well, in order for us to be able to calculate this effectively, we need to be able to show that our curve is approximately normal. Okay. We need to show that we've taken a random sample, that there's no bias, and we need to show that we've met the 10% condition. Well, for normal, we have our 1,000 times 0.75 must be greater than or equal to 10, and our 1,000 times 1 minus 0.75 must be greater than or equal to 10. Well, we checked those above. So those are good. We know we have an approximately normal curve. Have we taken an SRS? Well, or a random sample. Well, yeah, it says that we took an SRS. And the last thing is, have we taken a 10% condition?
Good afternoon, Lake Braddock. Please pardon this interruption. It is time to find your bus. Here is today's bus announcement. If you ride bus 44, please meet at the flagpole. Once again, if you ride bus 44, please meet at the flagpole. Thank you, Lake Braddock, and have a wonderful day.
Bet you can guess why I'm making this. Well, we can assume that there are more than 10,000 young internet users. Right? So we've met our three conditions there. Now for our do, we're going to draw that curve again. Since I have already defined what p hat is, I can now label this as p hat. We know that 0.75 is here, and then we just need to show our bounds. 0.77 and 0.73. And we are looking for the region in between these two values. Right, we're trying to figure out, okay, what's the probability, or what percent of my sample proportions fall within these two? Right? Well, we know we have a normal curve, so we can use normal CDF. Our lower bound for this region is 0.73. Our upper bound is 0.77. Our mean is 0.75, and our standard deviation is 0.1037. When we calculate that out, we are going to get, I'm going to write this here, about 84.7%. So for our conclude, we're going to find that the probability a sample of 1,000 young internet users is within plus or minus 2% of the true proportion is 84.7%. So think about that. Think about the power of what we just stated. I'm going to tell you before the bell here rings. If I take a sample of 1,000 individuals and I find their sample proportion, there's an 84.7% chance that that sample will be within 2% of what the actual proportion is for the population. Are we starting to see now how maybe I can use a large sample to estimate what the true proportion is for a population? Think about that. There's an 84.7% chance I take a sample of 1,000 people and I'm within 2% of the actual population proportion. How can I use that knowledge to help me estimate what the true population proportion is? Right? Hope you found this interesting. Hopefully we're starting to think about how can I use this information to do some estimates of what the actual population proportion is. Hope you have a wonderful day. Good luck on your practice. And I'll be seeing you soon. I'm excited.